Hello. Today in this video, I'd like to talk to you about electromagnetism. Here, we're just going to be exploring the connection between electricity and magnetism, which is called electromagnetism. Now, to start talking and thinking about electromagnetism, we first need to kind of confront this idea of where magnetism comes from. Where do you believe it comes from? How do magnets work? What makes them tick? Well, we've already seen submagnets in our class already, and oftentimes when we think of a magnet, we think about something that kind of looks like this. A bar magnet, maybe it's got two sides, one's labeled north, one's labeled south. It's just kind of a permanent magnet sitting there. Now, this phenomenon comes from some different places, but ultimately it has to do with our friend, the electron. If you think about a little electron, they have a permanent, what's called magnetic moment, where little magnets are electrons. We can think about them as spinning, and they have a little north and a little south pole on them, and that makes our permanent magnet. That's where kind of most magnetism comes from. But if you think about this with this spin analogy, now electrons don't actually spin quite the way we think of them, like a little top on their head. But if we do think about that, it seems like we need this electron to be moving in order to make the magnetism happen. And so if you can imagine, if we took our electrons and instead of having them spin, maybe we just had them flow, let's say through a wire, that seems pretty similar to that same type of moving charge there. And in fact, that also can cause magnetism. So electromagnetism shows us that the same type of thing where we have electrons moving, we have electricity, shows that electricity is related to the same phenomenon that causes magnetism. So electricity and magnetism are parts of the same physical phenomenon. We call them different things, but truthfully, they really come from the same place. There's no difference between the electric force and the magnetic force on a fundamental level. There might be on the way that we experience it, but on a fundamental level, they're no different. Now, what this shows us then is that magnetic fields, both the kind of permanent magnetic fields, as well as some we're going to talk about here, are produced by moving charges. So produced by a moving charge. So if you take a look at this wire down here, and I have these electrons moving this way, this charge out here is going to feel a magnetic force from the wire because of the moving electrons in our wire here. Now, some examples of this that happen in our everyday life. Think about an electric motor. Speakers. Inside of even like earbuds or any speaker is a little magnet, and when you pump electricity through it by hooking it up to some device that can output electricity, that makes that magnet move inside that speaker. Or with an electric motor, where you take electrons, you push them through a wire that causes something to move by using magnetism, and that's how you get your motor to run. And so anything that has to do with converting electricity into probably some other type of energy probably uses some type of electromagnetism, where you have moving charges producing a magnetic force that then makes our motors, speakers, and other devices tick. Now, the really cool thing about this is that you can run this process in reverse. So if you move a conductor, let's say like a wire, let's have a wire here, and we were to move this wire either up or down or back and forth inside a magnet, we'll just have like our little magnet here, north, south. We move that wire through that magnet. That produces or induces two things. So the word for this, it induces, or induction, it's called electromagnetic induction, induces two things. Number one, that magnet is going to cause a voltage, an electrical potential between the two sides of the wire. We'll say the top's going to be negative here, and the bottom, so the top will be positive, and the bottom will be negative. Now, this voltage is technically called an EMF, electron motive force, or electromotive force, and the reason it's called that is because not only does it make a voltage, but if you have a voltage and you have conductors in there, it's a conductor, then you can have current flowing. And so it's also going to produce a current. Now, this sounds really useful, and it definitely is. This is used to make a generator. So anything you've seen where you can turn mechanical energy or some type of chemical energy into electricity is going to use electromagnetic induction, where you move some conductor through a magnetic field and that induces some type of a charge to occur. And that then allows you to harness that electricity, either store it or to use it immediately somehow there. Now, how you're going to be tested on this is through noticing moving charges and how they affect conductors here. So in this example question, I've got a small object. It's dropped through a loop of wire connected to a sensitive ammeter on the edge of a table, as shown in the diagram below. It says a reading on the ammeter is most likely produced when the object falling through the loop of wire is a what? Well, in order to have this loop of wire show a current, like we said, a conductor needs to be passed through a magnetic field. And so I'm going to need something magnetic to induce my current, and so we're going to be needing to use a bar magnet. The other type of question you're often going to get involves moving charges. If I had a wire here, for example, let's not even say a wire. Let's say that we had a magnetic field. So here's our magnetic field running from, it always runs from north to south. If I had an object go through that magnetic field to produce that, it would need to be a proton or a neutron. I'm just going to cut all this stuff out. Okay, that's been electromagnetism. Okay, that's been electromagnetism. Thank you so much for watching. I'll see you next time.